So one of the last things that I want to discuss in this section is how does these matrix operations relate to what we've learned in the last two sections. So in the last two sections we learned how to solve system of equations. In the first section we did it by substitution and elimination. And in the second section we did it by Gaussian or RREF, row reduction. So how does that actually fit in with what we've just learned here? Well, let's actually just look at a very specific system of equations then. So we see that we have the same system of equations that we've seen in both section 1 and section 2. Okay. Well, now I want to write a matrix equation using the operations that we've just discussed. So addition, subtraction, scalar multiplication, and matrix multiplication. Well, the way that we're going to do this is we're going to separate our coefficients and our variables over here, and then we're going to set that equal to a matrix over here. So let's start with the right-hand side of this equation because that's going to be easiest. If I just take these numbers and put them into a matrix, my matrix is going to look like this, 3, 5, 1. And it's okay for a matrix just to only have one column, or like we saw in the last application, one row. It's no big deal. It doesn't say a matrix has to be any specific dimensions. So this is my column matrix. Okay, now let's look at my coefficients. Just like we did when we put it into the augmented matrix, all we did was we looked at the numbers in front. So this would be 4, 2, negative 1, 9, 0, 1, 4, 5, negative 2. So I have my coefficients. I need to multiply them by something to get my answers here on the right. Well, the only thing that I've left out at this point is my variables. And notice my variables are set for each equation. Their x's here, their y's here, and their z's here. So I can summarize that with a column matrix, an X, a Y, and a Z. So if I were to actually multiply out these matrices here on the left, I would take this row times this column, 4 times X plus 2 times Y plus a negative 1 times Z, which would give me exactly this right there. And I could do that again for each respective one, and of course we would see the pattern. If I took this row times this column, I would get 9 times X plus 0 times Y plus 1 times Z. And of course that's equivalent to this guy right there. And same thing for the last row. And so if it wants us to set up a matrix equation, we have just done that. We've done our matrix multiplication here on the left and set it equal to our column matrix on the right. Okay, well, what if we wanted to denote these with very specific labels? And so, let's just call this a matrix A. We call this matrix X, and so this is a capital X here, hard to see. And this is equal to matrix B. And so we have matrix A times matrix X, or a lot of times we just say A times X, is equal to a separate matrix of B. Because all we did was summarize our matrix multiplication over here. This is going to lead us into the next section, is if we have a system of equations like this, well, how do we solve for it? Well, if this was simple math, if I had AX is equal to B, I would just divide by A to isolate my X, and I would get X is equal to B divided by A. Well, the problem with that is that means I would have to be able to do division. Notice I didn't teach you matrix division here because there is no such thing as matrix division. Well, if I cannot divide by A to isolate my X, then what operation do I have to use instead? Because I have to be able to isolate my X variable. I have to be able to isolate this matrix here because that's going to give me what my solutions are. And so that's exactly what we're going to learn in the next section, is what operation defines matrix division, because there isn't any matrix division 1. And once we learn that, then how do we use that to solve this system of equations right here? So the only thing that I have yet to cover in this section is how to check all of your answers using your TI-83 or 84 graphing calculator and using it in matrix format. How do we add, subtract, scalar multiply, and actually multiply matrices using that graphing calculator? And so that's what I'll be covering on the next and last video.